Good morning. This is Math 8. It is the 18th of October, 2019, and we're going to learn about equations with no solution, infinite solutions, and one solution. Beg your pardon?
With an egal.
With an egal. Andrew, what is the learning goal?
I can solve linear equations in one go.
Sophia, what is the why?
Math has its own language and rules. By solving equations, I can learn the language of math and how it works.
Excellent. Not every problem is solvable. Some apparent solutions in the physical world are not possible because they defy the laws of physics. Perpetual motion machines are an example. In math, there are some equations that are not solvable. There are also equations that have infinite number of solutions. Today we're going to look at those three possible situations: one solution, no solutions, or infinite solutions. More than anything, today is about being able to look at something that's written in math and identify what's going on. This is a skill that you will use in the future, not with math equations, but with other things. Doctors can identify different diseases, correct?
Yes.
They look at all the symptoms and they line it up and say, this is the disease. Can an auto mechanic identify different problems in a car?
Yes.
Yes. He or she looks at all the symptoms and says, this is the problem. Actually, I just built a house. Can a home inspector walk through a house and look at things and say, this was done correctly, this was done incorrectly?
Yes.
That's what you're learning, just with math symbols. You're learning how to look at things and identify what's going on. So here is an equation. Let's get this one to your notes. 2x plus 4 equals x plus 8. Earlier this week, I gave you a flow chart on how to solve equations. First step was distribution. Is there any distribution to be done?
No.
Second step, combining like terms or simplifying. Is there any simplification to be done? You see some?
X plus x on the one with 8.
Okay, and what would that be?
2x.
Yes. What does it mean to be a solution?
It means if you plug it.
Mike.
Means if you plug it into the equation it answers.
Well, here's the deal. There's no number that you can plug in and make this work. I'm going to show you a new red marker of death move. You haven't seen this one before, but it's a legal move. We've been doing red marker of death that look like this. 4 for 4.
Yeah.
That's a normal one that we've been doing. 2x minus 2x. Cool. Well, here's one. And really, it's just this, but I do it a little bit differently. 2x equals 2x. It's a new red marker. What I'm really doing is going minus 2x and killing them both off at the same time. What am I left with after killing those guys off? Nate?
4 is equal to 8.
4 is equal to 8. Yeah, and you're going, it doesn't make sense, correct? There is no solution to this. There is no number in the world that you can plug in for x and make this work. Pick a number.
5.
Okay, 5. Ready? 2 times 5 is 10 plus 4. 10 plus 4, does that equal 10 plus 8?
No.
It doesn't work. Pick a number.
3.
Pick it. 7. That would be 14. Does 14 plus 4 equal 14 plus 8? No. It doesn't matter what you put in. There's no answer to this. You want to try 1? Oh, you're saying there's no answer. There's no answer. It can't be done. Now watch this.
1.
It's not 1. It's infinite solutions. Pick a number.
5.
Pi?
5.
5. 10 plus 4 equals 10 plus 4. It works. Pick a number. Pick a number. 2. 4 plus 4 equals 4 plus 4. It works. So some can have infinite solutions. Some have no solutions, some have infinite solutions, and some have one solution. So the question is, how can we learn to identify them? You don't want to do all the math. You want to look at it and go, that has 1, that has none, that has infinite. So I'm going to give you a tree map that's going to help you identify it. You ready for the tree?
Yes.
Here we go. All right, Sophia. If you get down to something like this, ready? X equals, pick a number.
4.
3. That's one solution. I'm going to give you a whole, let me fill in the entire tree map first and then ask the question.
Do you want the tree map in our notes?
I do want the tree map in your notes. That's a great question. And thank you for asking that. So let's get this tree into our notes. Who are we missing? No, we're not missing. That's that. I'm missing Cameron. I'll take attendance before you guys get this started. Cameron, Cameron? Oh yeah. Being Cameron. Camping in a camper. 9. Over here in this example, we ended up with what? 4 equals 8? And that's a none. So pick any 2 numbers that aren't the same. Give me 2 numbers.
16 and pi.
Don't get crazy.
16 and 18.
How about, give me
1 and 2. 4 and 2.
4 and 2. 2 equals 4. That means there's no solution. It can't be done.
7 equals 8.
7 equals 8 would be another example. The infinite solutions,
1 equals 1.
1 equals 1. Pick another one.
2 equals 2.
2 equals 2. 3 equals 3. That means they're infinite solutions. And what we're going to do is I'll give you an equation and you kind of match it up with this tree map. I'm going to give you some more information. On one solution, the variables, stay with me. Stay with me. The variables don't cancel. Variables don't cancel. That means the red marker of death and destruction isn't going to do something like that. You always have an X. But none, the variables do cancel. And on infinite, the variables do cancel. In your notes with this stuff. So how do I tell these 2 guys apart? Because here, the variables cancel, the variables cancel. This one's good. Variables don't cancel, I know what it is. But here, variables do cancel, variables do cancel. How am I going to tell those 2 apart? Now it comes down to the air bubbles. Air bubbles don't cancel. Over here, air bubbles do cancel.
You're like that rapper, what's his name? He's like super rich and he's like throwing Mickey ice. And then Mickey's like a giant polar bear.
You are going to tell me one, none, or infinite on your whiteboard. It can just be the number one, none, or even the infinite sign if you want the infinite sign. There it is.
Wait, what?
Right here. You're going to tell me one, none, or infinite. You're good. Good. Coming back to answer. Good. Coming back to Michael. Good.
Can I borrow mine?
Get one off the board. All right, so I'm going to give you one. Try this one. When you're done with it, I have a little blue bucket back there. Put it in there by the rulers. This is, yes. Are there any in my blue thing over there? I did not do a supply check this week. That is not good. Okay, one. This is one solution. Notice, is there any way for me to use my red marker of death and make the x's go away? No. Can't use it?
Variables don't cancel.
This, one, none, or infinite. Good. Good. Coming back there. Good. Good. This is no solution. Right. No solution. It looks like a no solution right there. What is this telling me? Good.
Infinite.
And if you just want to go with like an abbreviation, that's cool also. Speed it up. Good. And Marvin? Infinite. Good.
Infiniteness.
This one, none, or infinite. Yes.
Wouldn't the last one be one? Because you can't have anything else that you create.
Let's go to our map here, our tree map. One would be like x equals some number. That's not what I have. None would be like 2 equals 4. It's not what I have. Infinite would be 3 equals 3.
But how is it infinite solutions when there is one number?
This is what the equation started. Let's imagine it started like this. And then I use my red marker of death, and I actually cancel those guys out.
Okay.
And what am I left with? 8 equals 8. It tells me that they're infinite solutions. Next one. One, none, or infinite. I'm going to just like try to push down the entire row at once. Coming back to this one. Yep, come back here. So, Marvin, if I went up here with my red marker, could I somehow get this x to cancel out?
No.
So I'm going to have an x no matter what. That tells me it's one solution. And I could solve it. I could subtract 3 and divide by 2. What is this telling me? Come back here. Good. Waiting there. Good. This is telling me infinite. Because if I did the red marker, the x's would be gone. I'm left with 0 equals 0.
And
That's an infinite. What is this telling me? Good. Good, 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 good. Good, 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 good. None. This one, what is it telling me? Good, good. Good, 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 good. It's telling me infinite solutions. Infinite. Ooh. So I've got some people saying none and some people saying one. Well, before I even answer it, I'm going to red marker of death and destruction it.
Everyone's like,
Ready? Red marker of death and destruction. Ah, looks like all the X's are gone. Boards again. Re-answer it. All the X's are gone. Show me the boards again.
Yeah. Did you have that?
Because say x is 1. Yeah.
Good.
Say x is 1. 2 plus 1
Good, good, good. Good.
is definitely.
So, look, all the X's are gone. What am I left with? My variables do cancel. All my X's are gone. I'm left with 0 equals 3. What does that tell you? Good, 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 good. 0 equals 3, which tells me it's a no solution. This one. What is this telling me? Did you red marker it in your brain? I'm going to start on this side.
Yeah.
Good, good. Good. Good, good. Good, 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 good. Are you happy with that answer? Red marker, right? Red marker of death. Goodbye. Goodbye. Ooh, actually these guys kill each other off too. I'm left with 0 equals 0. What does that mean? Infinite.
So,
Good. Pick a number. 32. 32 plus 2 is 34 equals 34. It worked. Pick a number. 4. 4 plus 2 equals... It worked. If I plug it in, it works. Pick a number. 17. 17 plus 2 is 19. 17 plus 2 is 19. 19 equals 19. It works. Every number works. What is this one telling me?
No.
Good, good, good. I'm waiting for you. I'm waiting for you. Good, 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 good. Look at, match it up with what's in the tree map. Good, 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 good. I have this as a 1. No, a none, right? A none, because it's like this. 7 equals negative 7? That doesn't make sense. Good. Oh, is that the next one? Yes.
So do negative variables mix with positive variables, or do they?
These are air bubbles, but
Air bubbles, yeah.
they can. I don't understand. I mean, air bubbles play with air bubbles. These don't cancel each other out.
So they're not air bubbles.
Well, they are
They're
air
separate
bubbles.
air bubbles.
The red marker.
Okay.
Can't cancel. Because what I'm really doing here is I'm going plus 5, I'm actually going minus 5, minus 5. And so here I go minus 3, minus 3. Well, that's going to cancel. It's going to be 0 equals negative 6 when I'm done.
Okay.
So in order to cancel on both sides of the equation, it's got to be identical. Ooh. Yes, yes. Yes. Looking at the tree map. Yes, 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 yes. No. No. It should be 1. Let's match it up. X equals 0. Where does that fit into the tree? Does it fit into 2 equals 4? Does it fit into 3 equals 3? Does it fit in with X equals, it fits in over here. X equals some number.
Oh, I thought if you like cross out the X and become
But
0.
what could I red marker it with?
Nothing.
Looking right here, there's not anything I can cancel it with.
Oh.
What is this telling me? Good, good. Good, good. Good, good, good. Good. This is none. What is this telling me? So, look at the ones.
Oh.
What a 1 looks like an x equals 3 or something. What does this look like? This is an infinite. Good. Ah, no. Notice if you red mark it, that's a destruction. It's actually going to go away. Good, 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 good. This is going to be a none. Who can red marker this? Okay, Bot, come on. Uh-oh, the world's going to see you in your pajamas. It's pajama day! Woo-hoo! Mr. Barr doesn't want to wear pajamas to work. There it is. And what am I left with now? -1 equals what? Equals 0. And that tells me no solution. What does this tell me? Good. Good, good. It's telling me infinite. Ooh. Step 1, distribute. Step 2, combine terms. Step 3, make your decision. I'll start over in the middle. I'll start right here. I'm starting right here, man. Pressure's on you. Pressure. On your pressure. That's Ice Ice Baby.
No.
No?
No, I know, yeah, I know. Yeah, I'm with you.
Ice Ice Baby.
He stole it. You're saying, I agree. So what is it, 1 none or infinite? Good, 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 no. Good, good, no. Good. Well, this is 1.
I just did the math.
Here, let's do it. Distribute 2x plus 6. Bot, red marker it. Is there anything to red marker?
No.
So I'm going to have an x no matter what. If I have an x, it means there's 1 solution. Good. Good. Good work. Good, good.
There's no solution, is it none?
You think
I
there's
mean, if
1.
there's no X, then
What's going to happen to those x's?
Well, there is no solution because
There is no solution right here. Would these guys cancel out? And would I be left with 0 equals 9, which is no solution, yes.
I thought that they had to be on a different side.
But so the red marker can do a lot of different things. Can the red marker right here, does a 2x cancel a 2x? What am I left with? But if you go into how to solve an equation, step 1, distribute. Step 2, combine like terms. Step 3, now go into this table. So after combining like terms, I'm left with 0. So maybe it's not a red marker, but the new red marker I taught you today was this, which really isn't new. What you're really doing is subtracting 2x from both sides, which is the red marker twice. It's the same idea. You want to fix it?
Is it a new one?
Good, good. No. Good. So right here, step 1, distribute. There's no distribution. Step 2, combine like terms. -2 minus -2. 0 equals 0. Make your decision. Infinite solutions. You, my wonderful people, you have homework tonight unless you get it done right now. And you have enough time in class.
Which one is it?
I still